Hello dear subscribers. In this episode we have news mini section and book review by Professor Haluk Aaron about car hackers. Also we have a dear guest, Cristina Menendez Romero from BMW Group talking about the behavior of the autonomous cars on highways and related topics. Our dear volunteer Professor Ansar Yasser will conduct the interview. Won't keep you waiting. This is the news mini section for November 2018, episode 49, and I'm Dr. Mariam Kavashkar reporting. Have you heard about Peloton? Yes, a group of cyclists, but what about autonomous driving? Well, Apple has filed a patent for a set of intriguing new autonomous vehicle features called Peloton. The whole idea is to enable the multiple self-driving cars to share battery capacity via a connector arm, to dynamically adjust positions, increase efficiency, and more. The number of cars in Peloton can start from 2, but many cars can be linked together to form a caravan. One of the benefits is the increase in aerodynamics. The vehicle can include a power management system which enables the vehicle to be electrically coupled to a battery included in another vehicle, so that driving range differences between the vehicles can be reduced via load sharing via the electrical connection. The vehicle can include a power connector arm which extends to couple with an interface of another vehicle. If you want to know more, we have included the link for the full patent on our website. Ford is about to launch a fleet of autonomous cars in Washington. Initially a black Ford Fusion equipped with a group of laser sensors and 9 cameras prepared a map of Washington. The mapping specialists from Argo AI were driving it in manual mode. Ford will announce that it plans to deploy a driverless fleet to carry customers and make deliveries across the US Capitol. We realized very quickly that we can launch a small number of cars in an area right away, but then not create a healthy business that helps the city, said Sharif Marakbi, President and Chief Executive of Ford Autonomous Vehicles. Ford noted that the district's openness to driverless operations gave Washington an advantage over other less welcoming cities. At the moment, city law requires a backup safety driver in autonomous cars, though officials said they would work in coordination with Ford to update those and other rules. In Florida, the federal government is going to shut down one of the modest projects of self-driving car, a driverless school bus operated by private transit company Transdev. This project has been running from September 2018. Unlike any other driverless car operating in the US, the speed doesn't exceed 8 miles per hour with a safety operator on board. The capacity is only 5 students and it travels through a single 3-block route all along sparsely trafficked, privately owned roads within town. Only on Fridays. School buses are subject to rigorous federal motor vehicle safety standards that take into account their unique purpose of transporting children, a vulnerable population, reads the NHTSA's press release. In June, one of Waymo's driverless cars crashed. Apparently, the lone safety driver had fallen asleep behind the wheels. He dozed off after one arm manning the vehicle and pressed the gas pedal, which turned off the autonomous mode. The sleeping driver didn't respond to any of the warning signals, warning about the manual mode activation, and finally crashed into the median of the highway. Waymo got lucky with the accident. The safety driver wasn't hurt, and no other vehicles were involved. Waymo reported the vehicle sustained moderate damages to its tire and bumper. The company said in a statement, constantly improving our best practices, including those for driver attentiveness, because the safe and responsible testing of our technology is integral to everything we do. Unlike many other companies, Waymo is striving for a car which is fully autonomous and doesn't need human interference, so it has cut the number of safety drivers in test from 2 to 1. With an ongoing race to make driverless cars, it's difficult to avoid crashes. Tech.co has analyzed autonomous car crash report records. And it's little wonder that California residents have mixed feelings about the testing taking place at their doorstep. Cruise and Waymo are the biggest offenders, being involved in 51 and 37 crashes respectively. Although Apple is very secretive about its driverless car project, but it could not keep it a secret that in August 28 it had a crash and also suffered another in October. This report by Tech.co doesn't include Tesla's and Uber's crash. People of California are used to this fact that their city is an innovator's hub, so seeing new technology every now and then won't be a problem. However, the driverless cars have had some conflict moments with pedestrians. On January 2017, a cruise vehicle waiting for pedestrians to cross the road, when another pedestrian ran across the road shouting and struck the left side of the cruise AV's bumper. One more in September 2017 with a cyclist, and other one in January 2018 with a taxi driver. As connected and autonomous vehicle technology continues to make progress, which countries are best prepared to take advantage of its massive potential? Although US comes up quite often, a country in Europe tops the list, and it is Netherlands. A KPMG study released earlier this year assessed countries on 26 variables within 4 pillars: policy and legislation, technology and innovation, infrastructure, and consumer acceptance. Singapore comes in second place for introducing an amendment to its Road Traffic Act that allowed self-driving vehicles to be tested on public roads. Talking about Europe, let me tell you about Oslo. Ruter, the mass transit company for the Oslo metropolitan area, is about to start testing autonomous buses in the Norwegian capital. Ruter's CEO Bernd Reitan says detailed plans are being worked on, with the goal of having autonomous vehicles in traffic as soon as possible, and that means early 2019. His view of traditional bus transport has been, our current business model is transporting people from locations where they aren't to places that are not their destination. To solve that misalignment, his vision is to have small autonomous vehicles circulating between neighborhoods and bus stops as feeder services for the regular bus lines. However, current Norwegian legislation puts severe limits on operations with autonomous vehicles on public roads. Among the restrictions are a speed limit of 12 km per hour or 7.5 mile per hour, a maximum load of 6 passengers, and a requirement to have an employee on board at all times to operate a manual brake if necessary. In May, mass transit company Columbus in Stavanger, southwestern Norway, won the first license granted in Scandinavia to run an autonomous bus service on some of the city's public roads. That's all for this episode's news. Thank you for listening. This episode, Professor Haluk Eren from Fırat University, Turkey, has reviewed a book about hackers, and especially car hackers. Getting close to 2021 and the era of autonomous vehicles, this is a very interesting book to read. Go ahead, Haluk.
This is the book review section for ITSPodcast, read by Dr. Haluk Eren, Fırat University, Elazığ, Turkey. The book title is The Car Hacker's Handbook, a Guide for the Penetration Tester, and consists of 304 pages, produced by No Stark Press in 2016, written by Craig Smith. Today's and future cars have many innovative IoT and computerized technologies. In fact, vehicle technologies are not hosting today's developed security environment, leaving millions vulnerable to attack. An average new car hosts about 100 million lines of software code to operate various vehicle systems, such as a standard navigation, infotainment, and connectivity system, which is one of the biggest areas of vulnerability. The existing book motivates the reader to understand vehicle computer systems, embedded software, and their vulnerabilities with detailed explanations of communications over the canvas and between devices and systems. Once you understand the vehicle's communication network, you can understand how to intercept data and perform specific hacks to track vehicles, unlock doors, glitch engines, flood communication using low-cost and open-source hacking tools, such as Metasploit, Wireshark, Kayak, Canyudels, or Chip Whisperer. The book begins with an overview of the policies surrounding vehicle security, and then delve into how to check whether your vehicle is secure and how to find vulnerabilities in more sophisticated software and hardware systems. The book consists of 13 chapters. Chapter 1 and 2 present specific threat models to assess high-risk vehicle parts and explain bus protocols for the various bus networks. Chapter 3 and 4 encapsulate vehicle communication with socket CAN interface on Linux, integrating numerous CAN hardware tools regardless of special equipment. They contain diagnostics and login to read engine codes, the unified diagnostic services, and related protocol, including different module services, common weaknesses, logged and stored place of information. Chapter 5 and 6 embrace reverse engineering to analyze the CAN bus network, virtual testing environments, CAN security-related tools and fuzzers. They elaborate ECU hacking by the firmware running on the ECU and explain how to access, modify, and analyze the firmware's binary data. Chapter 7 and 8 mention about building and using ECU test benches to remove parts from a vehicle for setting up a safe test environment, as well as reading wiring diagrams and simulating components of the engine to the ECU. They provide simple examples for attacking ECUs and other embedded systems. Chapter 9 and 10 talk about in-vehicle infotainment systems. They present different ways to its firmware and some open-source in-vehicle infotainment systems for testing. They explain vehicle-to-vehicle communication design and its weaknesses, including cryptography with different protocols. Chapter 11 and 12 comprise weaponizing CAN bus findings. They explain converting proof of concept code to assembly code and shell code, ways of exploiting only the targeted vehicle, and probing a vehicle undetected. They contain attacking wireless systems via software-defined radio, encryption schemes, and its weaknesses. The last chapter talks about performance tuning tools and techniques to enhance and modify a vehicle's performance and to tweak an engine. If you are curious about automotive security and hacking a two-tone computer, this book is obviously a comprehensive guide to reverse engineering and understanding the digital control systems in a modern vehicle. It is currently one of the top sellers in its category on Amazon, which could be a useful material for enthusiasts, practitioners, and professionals working on vehicle cybersecurity.
Thank you, Haluk. It was very interesting. Now let's listen to Professor Ansar Yassar, one of our dearest volunteers from Hasselt University, having a talk with Cristina Menendez Romero from BMW Group.
Hello, dear listeners. Today we are with Cristina Menendez Romero. In 2012, she finished her master's at University of Zaragoza. Her thesis was about robot navigation in dynamic environments. After that, she worked for automotive industry for almost 3 years, developing advanced driving assistance systems. Presently, she is a PhD candidate at the BMW Group under the supervision of Professor Bogard, University of Freiburg. She is interested in research topics around the themes of robotics, motion planning, navigation in dynamic environments, as well as the real-world applications on the automotive industry from advanced systems to autonomous driving. She and her colleagues received the first prize for the best paper in IEEE IVS ITS 2018. Dear Christina, welcome to our program. Would you like to add anything to my short introduction?
Thank you, Professor Ansar Yasser, for your nice introduction and for the opportunity to contribute on the podcast today.
Your paper titled Courtesy Behavior for Highly Automated Vehicles on Highway Interchanges won the prize for the best paper in IEEE IVS 2018 in China. Could you please give us a short introduction to this work and further on we proceed to the different parts of it, this paper?
Yes, of course. An autonomous system is expected to drive safely and on a comfortable way, but it should also be seen by the other traffic participants as a cooperative road partner. Our work focuses on courtesy behavior. We refer to situations that are not always defined by the regulation and where the solution arises from the politeness of the traffic participants. In my opinion, it's an essential requirement for the acceptance of autonomous vehicles to be able to provide this kind of courtesy behavior. We integrate the intention of the surrounding vehicles and assess different possible scene evolutions. We select the ego action that optimizes not only the ego values, but also includes the values for the other traffic participants.
As you have mentioned in your paper that there are other authors have worked on this theme. What are those and how do they differ from your current system?
Yes, when we approached this problem, we found some limitation we had to deal with. The behavior of the traffic participants is only partially predictable and accurate on the short horizon. Most of the state-of-the-art approaches use the most likely evolution of the situation, but the problem is that neglecting less likely situations could result in dangerous situations. Other approaches consider all the possible evolution of the states, which could result in too conservative systems, which are even not online feasible, maybe. We try to find a good trade-off between the computational cost and the exploration that allows our system to be robust over unexpected situations.
Have you heard about RSS by Intel, Responsibility Sensitive Safety? What do you think about it? How would it be its performance?
My opinion is an interesting approach. It's important to search guarantees of safety and to point out the limitation of statistical approaches. In the last IB conference, some approaches to study and focus on corner cases with more detail were also presented. I think they could also contribute to obtain more robust systems. I also find relevant the aspect that Intel mentions about the right-of-way rules. This idea of the right-of-way is given, not taken, and cautionous with respect to occlusions. It reminds me of another interesting work I saw on the Shanshu. It was related with the duty of exercising due care. The authors call it value-sensitive design, and these approaches share many points with our approach of providing courtesy behavior. In general, I think that the idea of using formal approaches to guarantee that the decision taken accomplished with the safety requirements is important, but we should not forget other problems related to safety like sensor or electric failures or even external digital attacks. Safety for autonomous vehicles is such a relevant field that, in my opinion, manufacturers, universities, and regulators should work together and share as much information as possible.
Your work has a very strong theoretical part. Please explain how it was experimented, simulated, and in real life put in practice.
Well, it was experimented step by step. We wanted to approach a complex problem and we divided it into small pieces. The first question was if our approach was able to show any advantages over existing approaches. We selected two available driving strategies and expand them with courtesy behavior. We compare them within a set of simulations and show that our metrics improved when we used our courtesy approach. But we also had some issues with the computational time, And when we analyzed them, we showed that the main bottleneck was the prediction we had selected. And therefore, we focused on reducing the prediction time. With another prediction approach, we compare again the results in simulation and obtain a good trade-off between the computational time and good metrics improvements, which was also able to be computed online on our vehicle. Then we went to our test track, to our testing vehicle, and we compared the approach with and without courtesy behavior, showing that our metrics improvement was also similar in the real world. Nevertheless, experiments on real world have often noise, and for this reason we resimulate for both configurations using the traces we measured. We showed that in resimulation and online results we had similar values.
What are your future plans for this research topic?
Well, we designed a simple experiment with one ego vehicle and one merging vehicle, but this approach is easily expandable to more participants. That's exactly what we want to test the next time on real traffic.
You have one more paper worth noting because some parts of the paper we mentioned before was based on that. Your other paper goes by the title of Maneuver Planning for Highly Automated Vehicles. Tell us something about this one.
The idea behind is that experienced drivers analyze and try to anticipate the traffic solution, and they choose their actions not only based on the current information but also on learned knowledge. What we propose is a planning system with a multi-level architecture, which is similar to the human reasoning process. We combine continuous planning with semantical information in order to deal with the complexity of the problem in a computational efficient way, but still be intuitive for the driver. We also explore in this paper the introduction of formal information to get a better gap assessment for the lane change.
What are your research topics at the moment? What are you working on?
Right now I am working on the lane selection and the factors that are relevant for the driver, also the subjective perception for the driver. And how can we weight these factors, maybe to individualize the configurations for each driver?
What do you think about the future of transport, let's say in 2030, when driverless cars, B2B, and others are quite common sight to see on the streets?
Well, I think it's going to be amazing. So first of all, autonomous systems can improve the safety and protection of the road participants, especially for vulnerable road users. Also, the idea of having driverless cars interacted with manually driven vehicles, how can we optimize the communication between machine and human is really challenging. The drivers will get the opportunity to decide if they want to enjoy the drive or let the vehicle overtake and use the time on a different way. But for me, the main improvement is still related to safety. As for example, V2X technologies can help us to extend the perception of onboard sensors and to cover some dangerous use cases, which nowadays, unfortunately, present high rates of fatalities. For example, to improve the protection against occlusion problems or scenes with reduced visibility.
Do you think systems like yours will solve the problems on highways? Let's say make them safer?
Well, I think it's important to provide the vehicles with courtesy behavior. To consider the intention of the surrounding vehicles could improve us to have a better traffic flow because it allows us to have a better foresight and to select smoother maneuvers. If each vehicle, not only the automated but also the manually driven, show respect and politeness towards the other traffic participants, the driving experience will be safer and funnier.
Dear Christina, would you like to add anything to this conversation?
I want to thank you, Professor Yassar and Dr. Kaveska, for the invitation to the podcast. and to thank my supervisor, Professor Burgar, my colleagues Mustafa, Franz, and Christian for their support and work in this paper. Especially, I would also like to compliment all people working and contributing to make our streets and roads safer. I think it's going on the right way. And of course, to the Intelligent Transportation Society for providing the platform to share the knowledge and research and to contribute to the discussion and improvement of the intelligent transportation systems.
Congratulations again to you and your colleagues for receiving the award, and thank you for being with us. This is Professor Asaya Sar from Hasselt University, Belgium, with Cristina Menendez Romero. Thank you for your attention. Goodbye.
Goodbye.
Thank you, Ansar. And a special thanks to Christina that accepted to have this interview. Well, that is for this episode. Don't forget to share and subscribe and check out our other media for other news. This podcast is sponsored by IEEE Intelligent Transportation System Society. This was Dr. Mariam Kavashkar from IEEE ITS Society.